hopefully we're feeling better about fractions. They're not so bad. They're just division problems, so we can always divide down, type it into a calculator, how we see it and all that stuff. If we saw 3/4, we always think if I needed to turn it into a decimal or do some work, I would divide down, type it into a calculator in that order, 3 divided by 4. If I had to do anything by hand, I'd kick that number out. And we practiced that. Adding, subtracting, multiplying, dividing, we did and tore through that. Now there's going to be times when we have to mess with a fraction and change it around a little bit. If we have an improper fraction, this right here, 5/3 or 5/3, if the top number is bigger, that is a problem. Now it's technically right, 5/3 is fine. But the best way to write it is as a mixed number. So they may ask us to do that. And the biggest reason we're doing this is because if we come to an answer that says 5/3, but that's not one of the choices, it's because we have to change it a little bit and convert it out. So the bottom number is really the important number. So what we're going to do is how many 3s can I pull out of a 5? If there's 5 things in here, 1, 2, 3, 4, 5, I can pull these 3 out and make a 1 out of it. And then I have these 2 left over. So this becomes 5/3 becomes 1 2/3. So that's how we change a mixed number to, improper fraction to a mixed number. So I'm going to do another example real quick. If I do 3 halves, if I had 3 half dollars, I got $1.50. I can mentally do that in my head. With some numbers, it's easy to do. I can do that in my head. If the top number is bigger, which it is, there's 1, 2, 3 in this 3. How many 2s can I pull out? I can pull out 1 set of 2. My 1, and that leaves a 1 left over. The bottom number is sacred for now, and it turns into 1 1/2. So that's how we visualize this stuff. And we're going to go over to here we go. How would we convert these? We have to develop an eyeball for this, that this is not good. This is stacking too much stuff up top. Stuff's going to fall over. The top number shouldn't be so big. So, or it should be like something that we just noticed. So that's the question. Here we go. 1, 2, 3, 4, 5, 6, 7. How many 5s can I pull out of that?
1.
1. There's my 1. And then there's 2 left over.
2/5.
You got it. So it's just like dividing with a remainder. How many 3s can I pull out of a 4? I can pull 1 set of 3s out of a 4 with 1 left over, and the bottom number moves on over. You got it. So that's how straightforward this is. Sometimes it's going to be more than 1, but we're going to put up some practice ones right now. So 1, 2, 3, 4. How many sets of 3 can I pull out? 1 with 1 left over. 1, 2, 3, 4, 5. How many sets of 4 can I pull out? 1 with 1 left over. Remember the bottom number is always sacred. 1, 2, 3, 4, 5. How many sets of 2? 2 with 1 left over. So, and then any way we can think about this stuff, if you think I have 5 half dollars, I have 5 quarters, I got $1.25, $1.25. Just convert it in your head, sure. We just want fractions. We want to demystify them. 1, 2, 3, 4, 5, 6, 7. We don't want to look at them as something that is pure aggravation. We want to look at it as something that we have learned to deal with. And in fact, 1, 2, 3, 4, 5, we're going to use fractions, and fractions are going to work for us in a lot of ways. to solve problems. 1, 2, 3, 4, 5, 6. One set of 5 with one left over. So that's it. That's the skill. And we nailed it. Now there are going to be times when we're going to need to change a mixed number into an improper fraction just temporarily to work with it. To be honest with you, it's probably not going to happen all that often on the GED test, but it's something that's pretty easy we can get to know. So what we do is, let me get rid of all that. If we had a mixed number, and for some reason, to work with it in math, we had to change it to an improper fraction. What we do is multiply here and add here. So, and we start at the bottom. 3 times 1 is 3. 3 plus 2 is 5. And then that bottom number sacred, that thing slides over. And that's how we turn 1 2/3 into 5/3. So we multiply at the bottom and then add the top, which makes sense because before this was a division problem and this was the remainder. So the opposite of dividing is multiplying. So we multiply and then add the remainder, the leftover pieces. Or if you play poker, the breakage. So if it was 1 and a sloppy looking 1 right there, 1 2/5. We multiply here and we add the leftover, the remainder of the breakage. So up we go.
Which is 5.
Add the breakage and that is
7.
7.
And the 5 is sacred.
Yep, 5, sacred number just slides on over. And that's how we manipulate it. So we're going to write a couple practice ones right now. We're not going to do a ton of these. Like I said, it's not necessarily a huge thing that's on the GED, but we want to be able to know it. So it's multiply and add, multiply and add. 5 times 1 is 5. Plus 3 is 8. That bottom number, sacred number, just slides on over there. 3 times 2 is 6. Plus 1 is 7. That number slides on over. And that's it. So it's multiply, add. And no problem. You know, if we did one out of money, let's pretend we're counting quarters. Got a drawer full of quarters, and we want to figure out how many quarters we have, or how many quarters we can get. So if I had $3.75, how many quarters would I get out of that? 12. And that just makes sense. $3 worth of quarters would be 12 quarters. And then we add the breakage or the leftovers. And now we have 15 quarters, and we can go play video games or any one of the ways that you can entertain yourself with a machine and a quarter. So that is mixed number to improper fraction. Okay, so improper fractions to mixed numbers, and mixed numbers back to improper fractions. I want my eraser. Where'd my eraser go? There we go. Now we're going to talk about reducing fractions. And this one is a little bit of labor. This one we're going to do a lot. So reducing fractions is getting something to its simplest terms. And we need to say that the GED is so good at writing questions where we have to do a little extra step here and there, convert something, change something, just so they can test, do we know how to do it? So one of the things that's going to come up is reducing fractions to their simplest terms. So this cleans up all the skills that we need to know with fractions. This is the old school way to doing it with the old pizza. that when we reduce fractions, that if you cut a pizza in half and I ate at least a half, I'm going to eat at least a half, the total number of pieces, 1, 2, is the bottom number. And then the part that we're talking about goes on top. So the whole number goes on the bottom, the part goes on top. So it's always part over whole. And 1/2 is the same thing as if I took the same pizza and cut it up into 8 pieces and I ate 4 of them. That's the total number of pieces, sorry. And this is the number that I ate. 4 out of 8 is the same amount of pizza as 1 out of 4. So when we reduce, let me get rid of that squiggly line, that's embarrassing. So when we reduce fractions, this is all we're doing is getting it down to its simplest terms. There are a lot of confusing ways to do this, and we're going to try to do it in the simplest way possible. All right, so the first question we ask is an improper fraction, and that's if the top number is bigger than the bottom number. That's what we worked on before about converting that stuff. So really, we should have that part should be pretty much taken care of. So next thing, are they both even? So do the digits end in 0, 2, 4, 6, or 8? So if we do that, if they're both even, we can at least cut them in half. Even if they're big, fractions like this, we could figure out that we could at least cut those in half. And then if they're still even, keep cutting them in half, keep cutting them in half. So anyway, that's the first thing we do. Even some big ugly fraction like this, just cut 36 in half. And 72 in half. And yeah, there's going to take a little work. This wouldn't necessarily be a GED thing, but that'd be 18. And this would be 36. And I think you know where I'm heading with this. If I keep cutting that in half, I get to 9. And 36 cut in half would be 18. Now they're both not even. We're down to 9/18 now. Now we ask ourselves the next question. Are they divisible by 3? Well, the quick way we could check 3, 6, 9. 9 is divisible by 3. But any number, if it was 72, you just add the 2 digits together. And if that number that they add up to is divisible by 3, then the answer is divisible by 3. That doesn't mean 9 means anything. It's just an indicator. So both 9 and 18 are divisible by 3. So 9 divisible by 3 is 3. And 18 divisible by 3 is 6. And they're still divisible by 3. And very early on, I'm sure somebody could see really quickly that this was all going to come down to 1/2. But I just wanted to show all the work. It would hardly ever take that many steps. But improper fraction first. Are they both even? Cut them in half. Are they divisible by 3? Add any number together, and if the number is divisible by 3, then the number itself is divisible by 3. And then the last one, do they end in 5 or 0? Then they're divisible by 5. So we would divide that stuff out. There are obviously other things. 7s are very hard numbers to work with. There's no catchy little rule with 7s. But if something's divisible by 8, yeah, you can cut them in half a couple times and whatever. You always want to put yourself in a position of you're in the GED test. And the simpler the task, the less we get worn out. It's like engine wear. If you have a certain amount of energy and enthusiasm and positivity when you take a test, and at any point, anybody can get worn down. We just want our tasks to be sort of straightforward and smaller and not some arbitrary, gigantic set of rules for us to solve. So 95% of the time, these 3 rules will be able to reduce a fraction for us. So we're going to do some practice over on the whiteboard. All right, so this is just the even rule. If they're both even, we cut them in half. And that one's still even. Okay. The whole purpose of this is to imagine yourself in the test and going, how much of my positivity, my encouragement, my own good self-talk, feeling, I can handle the next question. How much of that stuff can we control? That if we just have a few set up little reflexes and reactions, then we're going to set ourselves up for a success. Okay, so we're just going to do these real quick. These are both even, so we could cut them both in half.
Mm-hmm. Right.
Not even anymore, so we just real quick go, they're divisible by 3. 3 goes into 3 once.
One time.
Divide 9 by 3, and we get 1/3. If we had started from the very beginning with cutting them by 3s, divide by 3, and 1 plus 8 equals 9, so that means 18 is divisible by 3. We divide that by 3. This would be 2. This would be 6. These would both be even. You could cut them in half again, and we're still going to get to 1/3. Same deal here. These are both even, so we can cut them in half. Now we do the 3 check real quick. 1 plus 5 is 6. 6 is divisible by 3, so we got to divide this by 3. How many 3s go into a 6? 2. How many 3s go into a 15? 5. And this stuff does get tedious. There's nothing fun about this, for sure. But we would rather fix a problem with the bow tie method of adding, subtracting like that, and multiplying, dividing, and then just only have to mess with one fraction than having to work on all the fractions and just make the whole process longer.